of the latest robotics technologies. There's big interest in robots that have the potential of working in disaster sites and other places that humans can't go into. The New Energy and Industrial Technology Development Organization gave a demonstration of a humanoid-type robot. In a hypothetical situation inside a tunnel after an earthquake, the robot maneuvers over obstacles toward its target.
In places where debris is piled up and the ceiling has caved, Jackson is able to use its hands to maintain a stable and low posture to continue moving forward. HRP-2 Kai can climb over debris and walk along a path that's as narrow as a balance beam. The developers say they want these robots to be able to carry out rescue work in disaster sites together with humans. They can carry out regular tasks such as checking for irregularities inside a tunnel to investigate if it's filled with explosive gases, how many people are injured, and provide information to rescue teams behind so that they can follow in with the necessary equipment. A robot that is being deployed at TEPCO's troubled Fukushima Daiichi nuclear power plant was also on display. The compact remote-controlled decontamination unit Raccoon was developed by Atox, a company engaged in nuclear power plant maintenance. This is the movement section, and there's a crawler attached here. On both sides. It moves with crawlers and decontaminates with this part. The one deployed at the actual site uses this brush head. This brush head turns and water comes out from here. To allow it to operate in environments with high levels of radiation, this decontamination unit is equipped with a hose that stretches about 100 meters. Since 2013, Raccoon has been carrying out work to decontaminate the floor surface of the No. 2 reactor building. It has finished decontaminating about 80 to 90% of the floor surface. The air dose rate has also come down somewhat.
And Utsuda-san, what's next?
Yes, next we have a short report on digital content technology from the Digital Content Expo.
I'm at the Digital Content Expo. Here you can experience the latest in computer graphics and digital technology. I'm now going to stamp this crocodile that I drew. The crocodile is starting to move. When the drawing is stamped with a sensor-mounted device, the outline is detected by a camera. From the outline, the object is analyzed, and an image to which movement has been added is projected. This data reading system has other applications. This time it's only an animal that's walking, but for example, the characters can play with each other or fight. It's applicable to that kind of content and is customizable as well. We call it a haptoclone. It's a device to mutually copy this environment and this environment optically and physically. In this way, I put a balloon here, and then a balloon appears in the image over there. Put your hand in and try touching it.
I'm putting my hand in here. Can you see it over there? Yes, I can. It looks like a hand is appearing three-dimensionally. Please touch this area. Yes, I'm putting in my hand. Oh, it feels like I'm actually touching your hand. It uses ultrasonic waves. This is a small ultrasonic speaker.
The positions of the objects in each box are measured, and the sense of touch is recreated using ultrasonic vibrations. The vibration of objects coming into contact is transmitted to both sides.
Ultrasonic waves are emitted at the point of contact of the objects in each environment. And as ultrasonic waves can emit power, if you have a light object like a paper balloon, you can push it down.
Mr. Makino says he hopes to continue his research so that it can be applied to long-distance communication.